For this part of the notes, we're going to look at how to find a p-value and then what sort of conclusions we can make for this chi-squared test where we're investigating whether there's a relationship between our two qualitative variables. So we're going to use StatKey to find our p-value, and then later we'll learn how to do this in SAS as well. And doing this in StatKey is very similar to what we've done for both the t-distribution and the normal distribution. The first difference is that instead of clicking on t or normal, we'll click on this symbol, which is chi-squared, and that's going to select a chi-squared distribution, because that's what we said our sampling distribution will be. Then we'll enter the degrees of freedom. We said previously that that's the number of rows minus 1 times the number of columns minus 1. Then in the top left corner, we're going to select right tail. Earlier in the notes, we said that if the alternative hypothesis is true, we expect large test statistics. And so this is going to shade everything larger than our test statistic. And then we'll just enter our test statistic along the bottom to make our picture match up with what I just described. So we'll see an example of this in just a little bit for the example that we've been working through. But depending on our p-value, what sorts of conclusions are we going to make? Well, we've been doing several different types of hypothesis tests throughout the semester. We did things related to population means, we did things related to population proportions, we actually also saw the equal variances test that helps us check our equal variances assumption if we're doing a test for mu1 minus mu2 to compare two population means. And in each of those, we've used the same process. We compared our p-value to our significance level, which is alpha. Usually that's 0.05. And if our p-value is smaller than that, 0.05, we would say that that is sufficient evidence that the alternative hypothesis is true. If our p-value is bigger than 0.05, we would say that that is insufficient evidence that the alternative hypothesis is true. And so we're going to do that exact same thing for our chi-squared test. And the only thing we need to remember is that we should put our conclusions in context of our problem and also whatever population of interest we have. All right? So if we go back to our example, we had a chi-squared test which had a test statistic of 13.872. We decided previously that that would follow a chi-squared distribution with 2 degrees of freedom, 3 rows and 2 columns. So 3 minus 1 is 2. 2 minus 1 is 1. Multiply them together, that's where that 2 comes from. And we are going to shade to the right of our test statistic for our sampling distribution. So let me go to StatKey real quick. I'm going to select chi-squared here. And once it loads, it's going to ask me for the degrees of freedom because there's lots of different chi-squared distributions. I will put in 2. And we've seen this picture actually on a previous page. I'm going to select right tail, and then I need to remind myself what the test statistic was. It was 13.872. You can already see that that's off the side of my page. And so if the null is true, these are the types of test statistics that I would see. So most of the time I'll see things between, say, 0 and 4, or 0 and 6 maybe. 13.872 looks like a very strange thing to see if the null model is true. And in fact, I would only see something more extreme than that with a probability of 0.00097. So way less than 1% of the time. All right? So we can look at this in the notes. You can see this same picture here. You can go to StatKey and try it on your own to verify it. But essentially we're saying that if there's no relationship between age range and whether or not people feel overwhelmed by the amount of information available, this would be really unusual. This would be really surprising if these two things are not related. So, because our p-value is quite a bit smaller than 0.05, that means we have very strong evidence to conclude that there is a relationship between these two variables. And remember previously that our data only included people between the ages of 18 and 64 in the US. So I might phrase this by saying, we have very strong evidence that among all US adults between ages 18 and 64, there is in fact a relationship between someone's age range, and whether they feel overwhelmed by the amount of information available to them. Now, what I want to point out is notice that we aren't able to say what that relationship is. You may recall that previously it did look to us like as people got older, they were more likely to feel overloaded by the amount of information available to us. The chi-squared test itself cannot reach that conclusion. It can only say there is some sort of relationship, or we're not really sure if there's some sort of relationship. So you would have to do something else if you wanted to say what that relationship is. All right. So the last thing for Notes 14 is I just want to show you briefly how we can do all of this in SAS. So just like previous sections, you've seen where all these numbers are coming from. You could calculate them if you needed to, but a lot of times we're going to use SAS to do this for us. So I've included on SAS On Demand a file called 14-overload, and this is what our data might look like. So for this example, similar to what we saw in Notes 13, I've got my age range variable, I've got the feeling variable, so overloaded or not, and then I've got a variable telling me how many people fell into each category. So this would be referred to as writing the data out as counts. We could also see this as raw data. So in that case, instead of having one line for each combination of these variables, I would have one line for each person, and I wouldn't have this count variable. I would just see this combination here show up 35 times in my data. And because I'm doing this as counts, I've got this line of code. If I wasn't doing it as counts, I would remove this. So again, similar to what we saw in Notes 13. And we're also going to use proc FREQ, so the frequency procedure, to analyze chi-squared questions. We're going to put proc FREQ data equals the name of our data set. The second line will start with the word tables. We're just going to put our first variable times our second variable. And I'm not expecting you to spend much time knowing like what each of these different things here is doing. These are basically just things telling SAS what information I want provided when I run the code. So when I write expected, SAS will give me the expected counts that we previously calculated. When I write cell chi2, SAS will give me those individual observed minus expected squared divided by expected, those things that helped make up our test statistic. It'll give me one of those for each of the cells in my table. When I write chi-sq, it'll actually do a chi-squared test and give me a test statistic and a p-value and things like that. And then these last three are actually because if you don't include them, you'll get so many numbers in each cell that it's hard to keep track of. So I'm basically just telling SAS, don't include those things, just give me the other things I'm asking for. And you can see below what that looks like. So this is the output that I would get. And what I want you to notice is, regardless of which options you choose, SAS gives you a little like legend or key over here in the left. So this is telling me that in each of the cells of my table, the top number is the frequency. This would be our observed counts. The second number is the expected counts. And the third number is that part of the chi-squared statistic that's just based on that cell. All right? So you can actually go through and verify that this first row is our table of observed counts from the first page. This second row is our table of expected counts that we calculated. And this third row is the 6 numbers that we added together to get our chi-squared test statistic. But what we probably really want is the actual test statistic and p-value. And so if you scroll down a little further in your output, you would see this table. And there's a lot of information here, but fortunately, we're actually just going to look at the very first row. So you'll notice on that row that we said that our sampling distribution had 2 degrees of freedom. We calculated this test statistic of 13.872, and our p-value, if you round it to 4 decimal places, was 0.0010. So these should match all of the calculations we did previously. Once you're done with Notes 14, we've just wrapped up here. There's an activity on Moodle called Activity 14. And this is just an example for you to start over with a new data set and practice all of these things that we just talked about. So setting up hypotheses, calculating a test statistic, you need the table of expected counts to do that, and getting a p-value, reaching a conclusion, and so on. So review this set of notes, work on the activity, and let me know what questions you have after that.